Hi and welcome. I'm trying to learn particle physics, today neutrinos, and after we've done that we're going to do Neckstretching, and if you participate in the Neckstretching, then it's that at your own risk. This is part 6 of neutrinos already, I think. Summoning the real neutrino into existence could exercise a number of other problems as well. So there are 3 neutrinos inside of each fermion, the electron, the muon, and the tau neutrino, but they don't find them often as all in 33.3%, so 1/3 each of the total amount. Sometimes we're finding more of some of them. And one theory is that they have neutrino oscillation, they can shift from one to the other one, just back and forth. So an electron neutrino can become a muon neutrino, now there are too many muon neutrino, the other way around. And now there's the theory of a fourth one, that there is a fourth neutrino somewhere in, but it has so little mass that it can't be really found, but it has an influence on the other one, something like that. But no, and that would answer a bit the question, why are these 3 neutrino types, muon, tau, and electron, not in the same amount there? If there's a fourth one, which you just can't find, and having a force on them, but it also makes them new problems. Summoning this real neutrino into existence would exercise a number of other problems as well. A heavier fourth neutrino could explain why the other 3 are so anonymously light, for example. Okay, these 3 neutrinos are very light, do they say? Well, they had something with 0.05 electrovolt, but I don't know, is electrovolt actually a measurement for weight? Whatever. Now there's a fourth one which then gets the weight, whatever. Via a process known as the seesaw mechanism, its increased mass would drive the masses of the others down, like toddlers going up and down in the seesaw. So it's okay that according to this theory, these 3 neutrinos are very light because there's a fourth neutrino which is very heavy. The same particles have also been proposed as a plausible candidate for dark matter, the mysterious stuff known to make up 27% of the universe. Okay, there's in the universe dark matter, and it's 27%, and maybe if there exists a fourth neutrino particle in all things. I didn't really get the explanation where all these particles are in, but they seem to be in everything. In every atom. They can be an explanation of what this dark matter is. Where 27% of the universe is this dark matter, and basically the humans have absolutely no idea what it is. Others say stereo neutrons could also, and stereo, I don't know why it's not stereo. Others say stereo neutrinos could also solve the question of why antimatter produced in equal quantities to matter at the start of the universe has now all but vanished. Let's read it again. Others say stereo neutrinos could also solve the question of why antimatter produced in equal quantities to matter at the start of the universe has now all but vanished. I'm reading it. At the beginning of the universe, we were all equally known. If so, 3 puzzles of modern physics would find the explanation with one theory, says Oleg Wojcicki at the University of Copenhagen in Denmark. Okay, 3 problems. What is this 27% of dark matter in the universe, which the humans don't understand? What is going on with the very light weight of the 3 neutrinos? And why are the 3 neutrinos not an equal amount? I think these are the 3 things. Alas, nothing involving neutrinos is ever simple. And if you thought neutrinos were difficult to spot, try stereo neutrinos. Okay, we're having already a problem with finding these neutrinos. It's already hard to see an atom or an electron, and these neutrinos are very much harder to find. And now this fourth stereo one, basically it's just a theory that it exists. For each experiment suggesting hints of existence, there's another negating it. Okay, whenever I think you understand the sense. But I want to understand the sense. Whenever they make an experiment, they sometimes find out there probably exists, and then they make another experiment that says probably there's not a fourth one. The most empathetic is the universe itself. Okay, that's a theory for or against it. The present-day arrangement of stars and galaxies and the faint surviving echoes of a Big Bang. If stereo neutrinos had existed throughout the universe's history, says Raymond Volkas at the University of Melbourne, Australia, when their presence would have caused the cosmos to look different than it currently does. Okay, we're saying the universe, how the universe looks. If there would be a 4 fermion, it would look differently. It would look differently. What's more, the reactor anomaly has recently been called into question. Several experiments now underway have put neutrino detectors closer to the nuclear reactors than before, allowing for a more accurate measurement of electron antineutrino disappearance. Although the statistical analysis of this data isn't yet sufficiently advanced to say anything for certain, preliminary results suggest the anomaly might have disappeared. Okay, we're gonna ending with the first part of particle physics here. What we just said was they having these neutrino detectors. I still don't really get it. But they're having here some type of neutrino source, and where the neutrinos are coming out. They're having here a photo camera, and then these neutrinos, which are passing in the form of photons, in the form of light, are then hitting this photo camera wall, and the photos, clips of them, whatever is made of them. Then we have found a neutrino. But now they are more intelligent in saying, hey, we're putting the camera, we're using a different technique and putting the camera closer. And I think we're down talking about, hey, let's put it a bit closer. I think we're talking about putting it really close. And now we have it's so close, because I think then what it means is neutrino is oscillation, but this neutrino is just switch. More neutrino is where, but it says I rather want to be an electron neutrino. And now we have too much electron neutrinos, because the moneutrino has switched from one back to the other one, because we have so little mass we can do it because of it. But now we're doing that all the time. Maybe one says it here on the travel, but if I put the camera very close, they haven't done it already, and they can see now more and more closer. Maybe these are actually all three always in the same amount. Okay, now the other thing. We had talked at one place, I can't find it, about something like that. Things could be brought together. Now I went back to the video where I didn't pay proper attention. Now with paying attention I still didn't really understood it, but it was that hydrogen exists and helium exists. And hydrogen has 1 electron and helium 2. And now it seems to be, that part seems to be based on pre-knowledge, with explanation that I don't have it really, that we can't really bond together because hydrogen has 1 electron and helium 2, and that bond fits. 2 hydrogen fits together in a molecule because they have both 1, and then I didn't get that part. That part wasn't explained because I think that was necessary to know previously. Because we then use both the same electron. We have 2 hydrogens and we both use the same electron, and the other electron just goes wandering. I don't get that part. But it seems to be very hard to fuse helium with hydrogen because helium has 2 and the hydrogen 1, and now it doesn't fit together. Now, and there was another thing that they took the helium, and there were muons. They took them the muons, and they took a muon and bombarded that helium with a muon. So they had that little helium atom, and they shot with a muon onto it. And they did do this in this big, whatever this I don't call it. And they were shot with this muon, 1 electron out, and that muon came now to the helium. And now they replaced 1 electron of the helium with a muon. And now there was a helium with an electron in the muon. And so the helium has, I'm going to make it a bit more clear now. The helium has 2 electrons, and they shot a muon against it, and the muon kicked 1 electron out, and now there's helium with 1 electron and 1 muon. And then the other thing, I think we brought the question up, was what is closer on the further away. There was said that the muon is heavier, and that is why the muon circuits way closer to the nucleus of helium than the electron. So the question was, what is closer? There was said that the muon is heavier first, and that the heavier one muon circuits closer, orbiting around the nucleus. So the muon is now circling very closely, and the electron far away around the helium. They are not anymore 2 electrons, both on the, I think by helium they are both on the valence. So now we are 1 muon very close to the nucleus and 1 electron further away. And now it happens that it is now possible to fuse the hydrogen with the helium with the muon and the electron. Because if now they come together, the hydrogen, I don't really get that part, could kick out that 1 electron, or that electron stays in, or it uses its own, I think the hydrogen brought its own electron with it. But now when it was kicked in, because the electron was so far out, also because it was much lighter than the muon, the hydrogen lost its own. I didn't get the part where the electron of hydrogen went to. Whatever. 1 electron disappears with 1 of the hydrogen, and now it could bind because now the hydrogen takes the electron which was of a helium far on the outside, and it's now all perfectly bound. The helium has still its 2 basically with a muon that was a replacement, and the other electron, and the hydrogen still has the electron, and that way it was possible to fuse together one helium with a muon and the electron, which it shares together with a hydrogen. So there's now the hydrogen with the electron and the muon and the helium with its muon and the shared hydrogen. And that way it was possible to fuse hydrogen and helium, which normally don't fit together because one has one electron and the other two. But now it was possible because the electron was far on the outside and could, because of that reason, kicked out, because the muon is much heavier than the electron, was on the outside, kicked out, and now it stick together. And they both fitted together. Whatever. I didn't really get it all. And this thing is called hydrogen 4.1. And I don't know what I do now with that information, but I wanted to say it. Now I'm thinking about, do I save it as a video, this information which I just said? I have a lot of missing links. Why do they bond together? Where does the electron go? And so on. But on the other hand, I have what 4.1 is, hydrogen 4.1. But here's one thing at the end. It doesn't hold very long after after a fraction of a second, it breaks apart again. But it works for a little moment, and that is enough to get some theories about how atoms work together. Now, I don't know what we do with the information, but I think it was more or less a part of particle physics. This is chemistry. That was now the particle physics and the chemistry. If you were here for particle physics, you can already get to the next part of particle physics. We will do now a short next stretching. If you stay and participate in the next stretching, holding stable stance, and we're doing the hydro tower. We are reaching with the arms wide to the side. Breathe in and reach with the fingertips. Breathe out the arms again down and reach with the fingertips as far as you can. And up and reach as far as you can with the fingertips. And down, reach as far as you can with the fingertips. And again, reach as far as you can. And out and down. And up. Reach in front and reach in front as fast as you can and make a circle. Reach up to the sides and back. Reach as far as you can with the fingertips. And the second arm. Reach as far as you can. And back, reach as far as you can. Now put bullseye arms up to the side to a T and pretend to fly like a bullseye does. And we release the arms up and out to the side. Breathe the arms up. Out to the other side. Again in. Out and down. Now the legs shoulder wide apart. Torn up, shoulders back. Breathe in. And out, head over to one side. Breathe again in. And out, chin down to the ground. Breathe again in. Out, lift the head and bring it back in the middle. And out to the other side. Breathe again in. And out, chin down to the ground. Again in, the head up. And over to the first side. Breathe again in. And breathe halfway out. And circle over to the other side. Breathe again in. And out the circling back. And in. Let's try it. Let's do a question. The feet are standing together, intertwining the a little time. We are intertwining the fingers behind the back, the shoulders back, breathe in. And out, turn the head over to one side and the chin down to the clavicle. Breathe again in. And out, pull the hands down to the ground. Breathe in, lift the gaze. Turn the head over in the middle and over to the other side. Breathe again in. And out, chin down to the clavicle and pull the hands down to the ground. Breathe in, lift the head and bring it back into the neck. And now we're doing the stretch of Venus. Shoulder wide apart, intertwine fingers behind the back, bring them over to one side, breathe into up. Out, head over to the side with the hand side, chin down to the clavicle, breathe again. And out, pull the arm in and have the shoulder down. Breathe in, lift the gaze, turn the head over to the other side, hands over to the other side, breathe in. Out, chin down to the clavicle, pull the arm in and shoulder down. In, lift the gaze, bang it in the middle. And the sky hugger, breathe in, lift the arms up. And lean back with the long arms, breathe out. Okay. And out, lean back. beginning. Arms down. And we're doing Beagle's wings, breathe in with the arms up. Hold it down. The last time in up. Hold it down. And now we're ending with a cactus collecting its stings. Breathe in with the arms up, bring the hands to touch, and lower the hands down to heart center. Let's pause for the next stretching short. Next stretching, I thank you very much, and next time.